Hi guys, welcome. In today's session, I will be covering Unit Standard 14944, and the title of this Unit Standard is Explain How Data is Stored on Computers. So the keyword in this unit standard is how data is stored on computers. So there's a lot of things that we need to cover in this unit standard, and also before we even store data into our computers, we need to understand the types of data that we have. So we'll tackle that on the first session where we'll cover the types of data that we have, your linear and non-linear, your binary, your boolean, and so forth, and also the structure on session 2 in terms of how data is stored onto our computers. So the first thing that comes in your mind is that in terms of data being stored on computers, we talk about the structure. So what could be the structure? If you can check on one of let's for instance, I have normally my lesson plan. So in terms of the lesson plan that I have, so this is the structure and how data is stored within this. I've got in terms of the parents, or I may refer that in terms of the DBMS, the database management systems, or if I may say, this is your object. So in terms of the object that we have for technical support level 4, I have all the unit standard. So everything that is administrative, where I have your training schedule, the reports, and so forth, it's being saved onto admin. And in terms of your unit standard, these are the project that we have for course, the PowerPoint presentation that is saved for all of uh, the unit standard that we have covered so far. So this is the structure that we talk about. So we'll tackle that in depth in terms of what do they mean by how data is stored on computers. So let's look on to slide 2, the outcomes. So the outcomes, what we'll cover, this session consists only of 2 sessions. So session 1, it's more of demonstrating and understanding of computer data types, and session 2 will describe in depth in terms of computer data structures. So let's tackle session 1, demonstrating and understanding of computer data types, on slide 3. So a data type is a classification that specifies which type of value a variable has. So I'll just stop there. I'll just pause there for now. I just want to go in depth in terms of what do they mean in terms of the type of value and a variable. So remember, a value can be in form of numeric, can be in terms of numbers, and values are more often referred as characters in this instance. Characters may consist of letters, so we refer characters as variable like your letters, or a combination of both your value and a variable that's more of your alphanumeric. So this is a classification which specifies these type, a value and a variable, and the type of mathematical, whether these types of characters, which are your value and your variable, the mathematical operation that it uses, whether you want to increment a certain value within a set of sequential or an array, depending on a database that you are using or a structure that you are using, or whether is it logic. Logic operators may refer to the type of data type that you are using, whether it's your boolean. Boolean, it's referred as your logical data operation. So in this instance, whether it's true or false or zeros or one, so that's what they talk about, or that's what they refer as to your mathematical relational. Relational, it's where you have your data, your DPMS, where how your tables, your rows and columns are stored. So data in terms of the values, your numbers or your characters are stored within that rational. And also on slide 4, we've got the primitive data type. So in this primitive data type, it's your basic, it's characterized as a basic structure. So this is just a basic structure for building more data types. So in terms of more data types within this basic structure, we've got your Boolean, you've got your numeric type of data types. So it depends what type of data type you're using, and it's just a basic structure. And these it depends in terms of the size and the type of variable values, and it has no additional methods. So it depends in terms of the size and the type of the variable values. So let's look in terms of what do they mean by these primitive data types, because the next question would be, what are these primitive data types? What do they mean by the primitive data type? So on to slide 5, we've got these data types. We've got your byte, which consists of 1 byte. 1 byte is equals to 8 bits. And you've got your short, your int, long, float, double, boolean, which is the 1 byte, and your character. Character stores a single character or letter, or the ASCII values. We'll go in depth in terms of the ASCII value in the next slides. So these are the data types, your primitive data types that they mention. The good thing is that I've managed to share this this slide onto the portal. You can just access it on the portal and go through these data type and with its description. So for instance, like as I've explained, for 1 byte, 1 byte is equals to 8 bits, and it stores the whole numbers from -128 to 128. So these are your whole numbers, and we refer them as integers because of now. The integers can consist of negative and positive values. Also on to slide 6, we've got the Boolean type of the primitive data type. So these refer to the type of computer which represent the values in two forms. It's either a true or false, and or yes or no, or zeros and ones, and these are also known as logical data. And also we've got the numeric type, and this numeric type data, which simply means numbers. So numbers can be in many forms, including integers, real numbers, currency, calculation, percentage, and binary numbers. So let's look into these many forms that they refer to. On the next slide, we look into the numeric data types. Looking at the first numeric data type, we've got the integers. It is consisting of the whole numbers and can be represented in negative as well as positive. It doesn't contain any decimal values. And also the real numbers, it contains decimal and fractional values as well, and it can be represented in also in negative and positive numbers. Also, we have your currency. It contains a special symbol which refers to a particular country, and also this type of numeric value is recorded till to 2 decimal digits. Remember, your currency depends in terms of the country that you are. So in South Africa, the currency that we have using rands and capital R. In USA, they use the dollar sign. It depends which country you are from. Also, we've got the percentage, which are values they are calculated out of 100 and can be denoted in a whole number as well as in decimal values. It has a specific percentage symbol of a percentage, as you can see on the screen that I've shared, which is used to indicate a percentage value. And also we've got your composite data type and your alphanumeric data type. So moving on to the composite, it's your combination of primitive and other data types. So in this instance, we group your primitive and other data type. So other data type may include your alphanumeric, where you've got a combination of your Boolean and letters, or your numeric data type and your letters. So that's in a form of your arrays. So for instance, on slide 13, as you can see, you've got your decimal kind of numbers that we have. And let's say, for instance, if we can include an E, so this is more of your grouping your data type, because it consists of your letters and your decimal number. So that's what they mean in terms of your composite data type. And also an alphanumeric data type, it contains alphabets as well as numbers. As you can see on slide 13, these contains alphabets and numeric numbers. So that is more of your alphanumeric. Moving on to slide 9, we have what we call the extended binary coded decimal interchange code. So this is an 8-bit binary code for numeric and alphanumeric letters. So what do they mean by that? So on to slide 10, you can see this is your E extended binary coded decimal. This is your 8-bit. So if we can count all these binaries or numbers, they equal to 8. So we've got 1, we've got 2, we've got 4, we've got 6, we've got 8. So these are your binary extended binary coded decimal. So each alphabet represent a binary number. So for instance, A, because of now the computers understands binaries, your numbers, your zeros and ones. So your A, for instance, is equal to this binary number. And also line 2, it is a coding representation in symbols, letters, numbers, which are presented in a binary language, as I've explained. And also each alphabetic or numeric character is represented with an 8-bit binary number, as shown on this slide. So this character, all these characters, if you can check on your keyboard, all these characters represent a certain binary. So character @ and character hashtag, they don't have the same binary number. And also character capital uppercase A and uppercase B also does not have the same binary code. So this is your extended binary code. But first, let's check in terms of your ASCII, which is an American Standard Code for Information Interchange. This is an 128 English character with each letter assigned to a number from 0 to 127. So if you can check onto slide 12, from 0 or from 1 up until to 127, each letter is being given a binary. Each letter is assigned a number. Sorry, each letter is being assigned a number from 0 to 127. So for instance, capital letter A, it has it's been given in decimal. So we look only on decimal. So we've got decimal, hexadecimal, octet, HTML, and character. So let's look at the character and also the decimal. So for capital or uppercase A, the decimal number is 65. So converting that into decimal, we have to use this formula on slide 13. So if, let's say, for instance, we want to convert letter 65, we want to convert letter 65, for instance. So we have uppercase A, so we want to convert 65 into binary numbers. So we need to use this formula. So we will say, how many times does 128 being divided by 65? So that has to be 0. So 128 does not get into 65. So how many times does 64 get into 65? It get into 1 times, and you minus 65 minus 64. So when you take 65 minus 64, it will give you 1. So how many times does 32 get into 1? 0. How many times 0? also 0, also 0, and 1. So this is a representation of a in binary code. So if you want to convert 65 in binary code, this is how you go about it in terms of converting. That's how you go about in terms of converting. So moving back onto slide 11, any symbol that requires 1 byte of storage, everything that appears on the screen, including graphic symbols, is considered to be a character. What do they mean by that? Meaning anything that you simply see onto your screen is a representation of a character, whether that is a letter or a number or anything or a symbol that is being referred as a character. So character is generally reserved for letters, numbers, and punctuations. Computers can only understand numbers, so an ASCII code is the numerical representation of a character. For example, an ASCII code for uppercase M is 77. So let's check onto slide 12. Let's check onto the number 77, and this is true. You can see 77 is a representation of the number of the letter M. So let's try to convert 77 into binary code. How do we do that? But first let's remove this. So we've got 75. Let's call uppercase M. Let's check 77. Yes, it's 77. So now how many times does 128 get into 77? 0 times. How many times does 77 get into 74? 1. So you take 77. Sorry, it's not 75, it's 77. So 77 minus 64, it will give you 13. So how many times 32 get into 13? 0. How many times 16 get into 6? How many times does 16 get into 13? 0. And how many times does 4 get into 13? It contained 1 times. So 13 minus 4, it gives you 9. How many times does 9 get into 2? 1 time. And 2 minus 7, it's 5. So how many times does 5 get into 1? 1 time. So that's the binary conversion for capital M. So let's just recheck. Let's double check the conversion. So how many times does 128 get into 77? Once. So 128 minus 77, that's 51. Exactly. I think I've made a mistake. That's no, sorry, I'm correct. How many times does 128 get into 77? It does not. It's undefined. It's 0. So how many times does 77? Does 16? Does 64 getting into 77? That's 1. So 77 minus it's 13. So how many times does the 32? Yeah, it's fine. So that's how you go about in terms of conversion. So now if, let's say for instance, since you were given the uppercase for M, so what about the lowercase for M? So the lowercase, its decimal number, it's different from the uppercase. So lowercase, it contains 109, and when you convert that 109, it's a bit different. So when we do that in binary code, it will give you a different value. So let's say for 109 for lowercase m. So how many times does 128 get into 109? 0. How many times does 64 get into 109? once, and 109 minus 64, that's 45. So how many times does 32 get into 109? Once. So we need to take 45 minus 32, that's 13. And how many times does 16 get into 13? 0. How many times does 4 get into 13? Get into ones. So we need to take 13 minus 4, and that is 9. And I think there is one number here which is not included. I think it's an 8 and 9. This supposed to be ones. Then the difference is 13 and 4, it's 9, and it's 1 1. So it'll be different compared to your uppercase. So that's how you go about in terms of converting. And that's it in terms of session 1. So moving on to session 2. Session 2, describe computer data structures, and we've got the types of data structures and examples. So let me explain what is a data structure. So a data structure is a storage, as I've shown. This is just a storage that you find. For instance, these are your storage. These are your object where you store data within it. So this is your parent, and it contains child and the data within that type of storage that you have. So it's a storage that is used to store and organize. So I've managed to organize data according to the parent. So the parent is the core, and it contains children within the parent. And within these children, we have data within these subfields. So it is a way of arranging data on a computer so that it can be accessed and updated efficiently. So different kinds of data structures are suited to different kinds of applications, and some are highly specialized to specific tasks. So for instance, you find that a relational data type consists of tables and rows. So that is different. How you configure or how you add tables, that is different compared to your network database model. And also, like for example, for instance, if you want to store data sequentially in the memory, then you have to go for an array data structure. So for instance, I want to save this kind of data. All these datas are the same. These arrays are the same. Let's say for instance, this stores about 5 gig. All these boxes will store 5 gig. And if let's say maybe these arrays are full and I want to save it to the last array, obviously I will have to apply in sequence for data to be moved from one sequence to another up until it reaches the last. So that's what they mean in terms of if you want to store data sequentially in the memory, then you can go for an array data structure. So there's an illustration of what I explained earlier in terms of the array data structure, where each memory location, these are just numbers, these are just allocations. They don't mean these are the allocations where they symbolizes in terms of the array where you find your indexes. Also, the types of data structure that we have your linear data structure, and which consists of your array data structure. So in linear data structure, the elements are arranged in sequence one after the other. So an array data structure is a pure example of a linear data structure. As the word suggests, linear, it's a straight line, so everything is in sequence. Elements in memory are arranged in continuous memory. All the elements of an array are the same type, and the type of elements that can be stored in the form of arrays, what I've just explained. Also, for nonlinear data structure, elements are not in any sequence. Instead, they are arranged in a hierarchical manner where one element will be connected to one or more elements, meaning in hierarchical data, one of the parent is connected to the other. So we have the parent, and in this instance the parent may consist of subdivision in this instance. So nonlinear structures are further divided into graph and tree based data structures. So we've got the first one, which is a graph data structure. So each node is called a vertex, and each vertex is connected to other vertex through edges. So what do they mean by that? Whoa, what are the nodes? Do they refer to the computer nodes? So let's look into slide 18. So these are your nodes that they refer to, and these are your vertexes and are connected through edges. So this is more of your graph data structure, which each node is called a vertex. So each node is referred as a vertex, and each vertex is connected through other vertexes through edges. So each node is called a vertex. Each node is called a vertex, and they are connected through vertexes. Am I speaking the correct term? Each node is called a vertex, and vertex is connected to other vertices through edges. So these are edges, and they connect the vertexes. So also we've got your A3 data structure. These are just a collection of vertices and edges. However, in a tree data structure, there can only be one edge between two vertices. So there's one edge between two vertices. So this is the parent. The parent consists of your subdivision, and the two one edge between two vertexes, one edge between two vertexes. So that's how a tree data structure looks like. And also on slide 22, this is more of your files. We've got types of files that we have. We've got your work file, which is your temporary program files, and your text files. So a work file is just a temporary file containing data, computations, documents, drafts, records, and etc. Also, your program files is your folder in Microsoft Windows for operating systems, where applications that are not part of the operating systems are installed by default. You may find that in your C drive. You can just check the program files in your computer on your C drive, so they refer your program files as those files. And also we've got the text file. Is a kind of a computer file that is structured as a sequence of lines of electronic text. If you can go to your Word document, if you can go to File, Save As, any folder, these are what Microsoft has in terms of if you want to save your document in these kind of files. So we've got your plain text, your PDF. The file format, in terms of the file format, it's different compared to your Word document. So these are different types of file that you find within the Microsoft Word. So a text file refers to the type of a container, while a plain text refers to the type of content. So we've managed to show you the plain text. So text files can contain plain text, but they are not limited to such. And also at a generic level of description, there are two kinds of computer files, which is the text files and the binary files. Also on slide 22, we've got the types of DBMS systems. But before we even move into the types of DBMS, we need to understand what do they refer to as a DBM. So a database management system, or a DBMS, is a single or set of computer programs that are responsible for creating, editing, deleting, and maintaining